Hi everyone. In this video we're going to look at how to plot polar curves using GeoGebra. If you haven't grabbed a copy of GeoGebra yet, you can download your own free copy at www.geogebra.org. So here's the idea. We've got a polar curve, r equals f of theta, and we'd like to plot it. Now how do we do this? Well, generally most graphing utilities don't recognize polar coordinates, or at least equations of polar curves, and plot them accordingly. The way you get around that is by converting a polar curve into some parametric equations. So a parametric curve. And here we're just going to use the conversion between polar and Cartesian coordinates. So for polar coordinates r and theta, we can convert to their Cartesian coordinates by x equals r cos theta, y equals r sine theta. And that's all we've done here. We've written down the parametric curves to be x equals r cos theta, but r is f of theta, and y is equal to r sine theta, but again r is f of theta. So now we've got the x and y coordinates defined entirely in terms of a single variable theta, the parameter of the parametric curve. And so then we take this and we just feed it into GeoGebra. So here we just use the curve command. And we use the x function as f of t times cosine of t, and the y function as f of t times sine of t. The parameter is t. Notice I've switched from theta to t. It's just easier to type when I go to fire this stuff into GeoGebra. And the interval we're interested over is, well, 0 to 2 pi, or really 0 to wherever you want. So this alone won't plot a curve. You have to have a particular function f in mind. So for example, the line before in GeoGebra may be to take f of t to be 1 plus cos of t, and then that curve command will now plot it. So let's go ahead and fire this into GeoGebra. So we start by going down to the input field, and I'm going to type in our function, r of, and we could use theta. You get theta by going over to the right hand side, opening up the window which has all the Greek letters in it, clicking on theta, and that's equal to 1, here we'll do 1 plus cos of theta. So I'll use theta again. There we go. So there's our r function. We hit enter. Notice though it's plotted it as if it was an equation in Cartesian coordinates. We wanted to plot this in polar coordinates. So I'm just going to hide it. And I'm now going to use parametric curves to construct the plot. We can force it to plot the points whose polar coordinates satisfy the equation by getting it to plot the Cartesian coordinates of that corresponding point using the curve command. And so we plot the curve in Cartesian coordinates by r of t times cos of t, r of t times sine of t. Parameter t ranges from 0, and we can go around to 2 pi. And there's the corresponding plot. So what we've managed to do is we took the polar curve and forcefully plotted all of the points whose polar coordinates satisfy this by converting them to their corresponding Cartesian coordinates and allowing the parametric curve to plot the Cartesian coordinates of those points. We can do the same thing we've done with other curves. We can change the color, we can go ahead and change the style, the line width, and there's our corresponding curve. And we can play around with this. We can change it to plotting the corresponding curve 1 plus sine theta, and it automatically updates. So you can go ahead. That's really all there is to plotting polar curves, is just converting them to the corresponding parametrized curves and plotting those. Now one thing we can do is we can sort of tweak this a little bit. I'm just going to blow it up, move it to the center. And what I'd like to do is have the point get drawn as the angles increase, as theta increases. Here the theta in the original equation is really represented by this parameter t. So I'd like it to trace the curve. So how can I do that? Well, I'm going to introduce a variable called capital T. I'm going to show the slider that corresponds to that variable. This allows me to change that number, capital T, and maybe we'll adjust where it ranges over. So capital T will range from 0 to, we can go around to 2 pi or 4 pi. Or I'm just going to go around to 4 pi. So that just says I've got a slider now where those T values could go from 0 all the way out to 4 pi. Now if I go to the curve and I edit the properties of the curve, notice the parametric curve is plotting from little t going from 0 out to, what was here was 2 pi. Instead I'm going to have it go all the way out to big T. And now if I click OK, see how it's only plotted a little bit of it? It's plotted all the points on the curve where little t goes from 0 out to big T. So now if I let big T range, it'll now start to trace the curve out. So there was, we just passed t equals pi. There's t equals 3 pi by 2. There's t equals 2 pi, and then it keeps going. Of course, I lost track of the point now. I could have it plot the point at the end as well. That's sort of laying this trail down and it's behind it. And I'll do that by saying, well, I want to plot the point A. Remember, the curve is A of t. That's going to plot the point on the curve whose corresponding parameter is capital T. And there it is right at the end. Go object properties. I'm going to color it red as well. I'll bump up the point so it's now 7 point. I'm going to hide the label. I'll hide the label on the curve as well. And now as we drag the slider, looks like that point is laying out the trail behind it. And then there's t equals 2 pi, and then it, since we graphed it from capital T going out to 4 pi, it makes these 2 revolutions. So very nice. And we can do things like, okay, change the function here. Maybe we'll go 1 plus, I don't know, let's say 3 times sine of, and maybe we'll go 2 times theta just for fun. So we're going to plot the polar curve, 1 plus 3 sine 2 theta. Everything's updated. Now we'll just let the slider drag it out. Okay, I'm going to zoom out a bit because we're losing it. And there we go. Oh, that's pretty cool. So there's our polar curve, and it's going around twice. So there's one shape completely traced, and we're now at around t equals 2 pi. So since t went out to 4 pi, it traces it out twice. All right, so that's how you can plot polar curves by first converting them to parametric equations. So feel free to start playing with these things, and you can now sketch all of the curves that are given to you in the exercises in the textbook and create the visualizations that go along with them.